Building a multi-track audio engine. I've been involved building a lot of software synthesizers and 2 digital audio workstations over the year. What I always needed was a way to manipulate a stream of samples. In this episode, I will show you how to open an audio stream and add 4 stereo tracks to it. I have made this episode as simple as possible, so what's important don't drown in an overwhelming amount of information. I organized the code in 2 classes, an audio engine class and an audio track class. I also added some audio files to the project. Inside my main function, all I do is to declare an audio engine and add it to the project. On the top of the audio engine, I import the following libraries: flash.vector, the sound library, the sample data event library, the binaries. I declared 2 constants, one for how many tracks there is in the project and one for the buffer size. This number is delivered by Flash and can't be changed. In my opinion, this is too big for real-time synthesizers, but of a mixer, it's okay. The audio track vector is used for the individual instances of the audio track class. We will look at that later in this episode. The sound object is what drives the audio stream. Although you could implement this example by just creating 4 sound objects, that's not the purpose with this episode. What I want to show is how to manipulate a data stream of floats. The sound buff is the actual stream of float I will perform the signal processing on. The byte array is what I have to deliver at the end of the processing chain to the sound object. The sample in song and channels loading is used for housekeeping. We will look at that later in the code. Functions. The new function called 3 other functions. Init. The init function initializes the variables we just created in the top of the code. The build tracks function push 1 new audio track to the audio tracks vector for each track declared in the top of the code. The load audio function loads the audio files I have stored here in a folder called audio files into each track in the audio tracks vector. This is not beautiful code I'm proud of, but for this example it's good enough. So now when the audio tracks load function is called, I will jump into the audio track and see what's going on. First, I import a bunch of libraries. Then I declared some variables. They're pretty much the same as for the audio engine. The exception is I have a pointer to the audio engine here. In the new function, I store the pointer to the audio engine, I reset the sound index to 0, and I create a new byte array. The load function we just called from the audio engine creates a new sound object. It calls the sound object's load function with a new URL request with the path to the sound file for the audio track we just passed on from the audio engine. Then it adds an event listener of the type event completed and a pointer to the unloaded function. Inside the unloaded function, I remove the event listener and call the audio engine's onAudio channel loaded function. Inside the audio engine's onAudio channel loaded function, I count up the channels loaded variable and I check if the channels loaded is equal to the length of the audio tracks vector. I guess that all tracks is not a guess. I know that all tracks is loaded and I start to play. Inside the play function, I do 2 things. I add an event listener of the type sample data event.sampleData and a pointer to the mix section. And I start the stream. And this is where I actually start the stream. the stream is started if you should be in any doubt. So now there's a constant stream of zeros and one running through the system. So within the mixer section, I do three things. First of all, I set the samples in the sound buffer, and that was the area of float we just created. And I give it a buffer size. And this is the same as dividing by 2. And we will look at that inside the audio track in a few minutes. And then I do something about the same, but with the rest of the tracks. I only did this for the first. And I said add samples and the same parameters. And then I call something called a function called write bytes to the event data I received here, and with the data from the master section. And this is a little tricky, so we will go through this at the end of the episode. So just for a short overview, set sample and add sample inside the audio track does the same. Besides, this one actually overrides the sound buffer, and this adds the value to the sound buffer. So now let's have a look at the audio tracks. The audio track set sample function takes the sound buffer declared in the audio engine. It was a vector of floats, and it takes the buffer size. It starts by setting the bytes position. The bytes is a byte array. That's the little chunk of data we're going to read now. And it called the sound object's sound extract function. And it passes in the byte array to where it will copy the samples from the audio object. And it takes, this is how many it takes, and this is from where. So now we have to keep our head clear. Because bytes, there are 4 bytes on one float. And this was a float. So I have to calculate how many bytes did I read. And also it's in stereo. So the byte position, samples read, you have to divide by 4. And the sound index, you have to divide by 2 because it was stereo. And then I declared a variable, and I set the bytes position, that's the one I use here, to 0 again. And now I fill the sound buffer. Yeah, our sound buffer, that was a vector of floats. And the byte array has a function called read float. So I don't have to bother by passing all the bits the right way so it becomes a float. So I just say read float, and it counts up itself and read the next float and the next float and the next float. So on, and at the end I count up, and when all the samples it's read, I go on. But imagine that the buffer size was bigger than how many samples were actually read. I have to fill the rest of it with zeros. So and again it's stereo, so I do it by checking and counting up 2 at a time. And the add sample does exactly the same. It's just a copy. The only difference is here it says equal, and here it adds to the sound buffer. Since it was the same sound buffer, I don't have to delete it. I just write down to it, overwrite whatever in it, and then for the other channels, I add to it. Let's go back to the audio engine. So that was what's going on here. And this one is the little tricky part. I will try to go through it. It's not that important. I added an event listener, and the event listener goes in here. The event has a data. There's some data in the event, and I can say write bytes to those. The data here is actually a chunk, a byte array of the size, this size. That was the default size from the sound object. So the master section takes my sound buffer and copies into the byte array with a function called write float, and that was similar to the read float we use in the audio channel, audio track object. So I go on and go on and go on until the buffer size is filled, and I return it. It goes return here and goes into the data's write byte function, that was actually used by the sound object. So now when the sound is running, and it's running infinitely, because I never say stop, but to avoid noise or weird sound, I just fill it with zeros at the end. So just to cap up, I declared an audio engine, I create it, and it starts running and playing the sound by itself.